Hi, you are welcome to GMath class. And let's solve the problem here. Now the first one, 3 square root of 3 plus 7 square root of 3. So we have to add this together. The number of square root of 3 that we have here is 3. The number of square root of 3 that we have here is 7. So the total number of square root of 3 we have here is 10. So that's 10 square root of 3. That's all. Now let's look at the second one. Square root of 50 minus square root of 18. Now look at this. They don't look alike. So I will try and convert this number to their basic form, the square root of 50 and square root of 18. So this is the same thing as square root of 25 times 2 minus square root of 9 times 2. So that gives me 5 square root of 2 minus, because square root of 25 is 5. So square root of 9 is 3. So 3 square root of 2. Alright, so we now have how many square root of 2 here? 5. So we are removing 3 square root of 2 from 5 square root of 2. So that means the answer will be 2 square root of 2. Okay, so that's the answer to the second one. Let's look at the third one. The third one, square root of 99 minus square root of 44 plus square root of 11. Now, you have to look at this. This must be converted to its basic form, and this one is already in its basic form because you can't get any other perfect square here. No perfect square will go in this apart from 1. So this will turn to square root of 9 times 11 minus square root of 4 times 11 plus square root of 11. So square root of 9 is 3. So we have 3 square root of 11 minus square root of 4 is 2 square root of 11 plus square root of 11. So you can see here that we have 3 square root of 11, 1 square root of 11. So that gives us how many square root of 11? That's 4. 4 square root of 11 minus 2 square root of 11. So when you remove 2 square root of 11 from 4 square root of 11, so you'll be left with 2 square root of 11. And that's the answer. Okay, now let's look at the fourth one. We have square root of 3 plus 1 over square root of 3 minus 1 over square root of 27. Now, I can see that this is a multiple of a perfect square. That's 3 times 9. So let me adjust to have square root of 3 plus 1 over square root of 3 minus 1 over square root of 9 times 3. Okay, so and that gives me square root of 3 plus 1 over square root of 3 minus 1 over 3 square root of 3. Okay, so what I'm going to do now is to clear the fraction. To clear the fractions, I will multiply the whole expression by the LCM of the denominator. So we multiply through by 3 square root of 3. But in this case, we can multiply through by square root of 3. We'll still get what we want. But let's multiply by the LCM of the denominator. So that gives you multiply this by 3 square root of 3. So we have 3 square root of 3 times square root of 3. Okay, I use it to multiply this plus 3 square root of 3 over square root of 3. Okay, minus 3 square root of 3 over 3 square root of 3. Okay, so this will give you 3. Now square root of 3 times square root of 3, that's 3. Because square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. Okay, so plus, now this we cancel this, so we'll be left with 3 here. This square root of 3 cancels square root of 3, so we are left with 3. So minus this cancel this, so we have minus 1, and so we have 9 plus 3 minus 1. So 9 plus 3, that's 12. 12 minus 1, 11. So our answer is 11. So now let's try the following question. Simplify the following surds. So you simplify this, and let me have your answer.